Okay, I'm going to talk about a Chesapeake Bay case study. I'll start by talking about some principles of Chesapeake literacy. You can go to the Ian website on April 2nd, where there's a blog and text supporting some of this literacy stuff I'm going to talk about. All right, 7 principles are that Chesapeake's large, shallow, and productive, formed by a drowned river valley, the Susquehanna River. In particular, the extensive watersheds connected to the bay by a myriad of streams and rivers, particularly vulnerable to runoff of nutrients, sediments, and toxicants. Climate change and land use alteration are major drivers of Chesapeake Bay and its watershed. It supports unique human cultures and livelihoods. In many respects, American history has been shaped by Chesapeake Bay. It's extremely well studied and intensely managed. This is a satellite. You can see the drowned river valley, the deeper areas in red and yellow here. Coming down the main stem, as well as some of the tributaries feeding into it, draining a large watershed. So it's very productive, and one of the reasons it's so productive is because of the shallowness, and another reason is because it's an estuary with this 2-layer flow with fresh water coming in, laying on top, and then the salt water down below, and this allows entrainment of particles and nutrients and organisms. And the sediment that comes in from the watershed, usually in pulses associated with runoff, have also bring nutrients with it, and naturally. And this salinity gradient of the bay is very extended. It's probably the most extensive, well, definitely in North America, from fresh water at the mouth of the Susquehanna to full-strength seawater at the mouth, over a 200-mile distance. And just to get an appreciation for the depth, there are these depth profiles for the upper, middle, and lower bay. And what you see here is the upper bay is largely, less than a couple meters deep. See, this is depth here, and this is the amount of area or volume at those depths. And you can see that over 50% of the volume is less than 5 meters, and a considerable amount of it is less than a meter. In the mid-bay, it's a little less so because we have the deep trough here. But even in the lower bay, which is the more oceanic, that's still actually quite shallow through much of its depth. And then the myriad of streams and rivers are shown on this map that shows that we have the major tributaries like the James, York, Rappahannock, Potomac, Patuxent, the Susquehanna, of course, and even our eastern shore rivers, but they're all bifurcated with lots of smaller streams, and so you really can't go very far in the Chesapeake watershed if you walk in a straight line without encountering a tributary of the bay. Now, the watershed covers these different physiographic regions. The big one, the one surrounding the bay immediately adjacent, is the coastal plain, which is very flat, and then moving up at the fall line. The fall line is where the transition from this tidal influence is stopped, and that's where the waterfalls occur, and that's of course where the big cities end up occurring. And upstream of that is the Piedmont. The Piedmont is the sediments eroded from the Appalachian Mountains. We have the Blue Ridge and then the Ridge and Valley. Blue Ridge is just really one of the ridge and valleys that begin as we move up into the mountains, and then finally the plateau, the Appalachian Plateau itself. So the majority of the bay watershed is very low elevation Piedmont, coastal plain, the adjacent to the bay, and then the vast majority of the upper parts are Ridge and Valley and Appalachian Plateau. The watershed is largely 50% is Susquehanna. The next biggest is the Potomac, and then after that goes to the James, and then these smaller York, Rappahannock, uh, rivers down here, and the Choptank is the largest on the eastern shore. But the Choptank's very small compared to all these western shore tributaries. So the vulnerability of Chesapeake is to this runoff of nutrients, sediments, and toxicants. And recreating the fall line here, you can see the urban development that is associated with that fall line, the red being urban development. We have our tidewater development down in the Newport News, Hampton area. And then we have development in the Susquehanna, the lower Susquehanna River Valley here. And then you can see this development, urban, but also these agricultural development. You can see those stripes in the valleys of the Ridge and Valley, and of course the entire eastern shore, and lots of western shore is developed as ag as well, and then forested areas up in the Appalachian Plateau and some of these Piedmont areas as well. So one of the reasons Chesapeake is so productive and so vulnerable to nutrient eutrophication is because it's naturally nutrient retentive. And that's due to a suite of different processes that all act to capture and retain nutrients rather than flushing through the estuary from the land source to the ocean. So there's 6 of these that were listed by Roman's paper. A lateral front that occurs with the pycnocline. The pycnocline is the density difference between the warmer, fresher water and the cooler, salty water underneath. And it can tilt depending on the wind direction. And as such, I can create a front when it's tilted in one direction. River plumes that come out create little hot spots, and of course all the fishermen know to pick on those areas where the river water meets the salt water. There's something quite unique to Chesapeake Bay is this convergence eddy, which has to do with the large size and towards the south of the bay, where you get this small eddy like you get out in the ocean that's set up from the Coriolis of the saltwater coming into bending to the right, and then creates this little eddy, which forms a little hot spot. Hydraulic control, another unique feature of Chesapeake Bay, is the water comes in and it gets it's pretty shallow down here, you saw from those earlier graphs, and then it goes down a little bit, and that creates a little dip, and there's a little hydraulic element that occurs there. And then 2 of these other features, which are common to estuaries throughout the world, are the estuarine turbidity maximum, where salt and fresh water mix, and there's a real concentration of resuspension, of particles, of zooplankton, and fish larvae. It's a real hot spot, a lot of research going into that. And tidal fronts, another thing that occurs in estuaries where you get in the mouth where the tides are ripping through, you get these small little fronts that occur. So all of those serve together to retain nutrients. And one of the consequences of this vulnerability is that Chesapeake Bay gets seasonally low oxygen levels, and you can see the map of dissolved oxygen in 2005, and down the main stem you see this lack of oxygen into the Potomac, and it's seasonal. You can see it in January in the cold water months. It's well oxygenated to the bottom, but then setting up in May, June, and then peaking in July and August. We get this hypoxia until fall when the water cools down and the winds stir it up and re-oxygenate the bottom. This has been a real problem, and really the genesis of the Chesapeake Bay program was this dead zone, these oxygen areas, and they started being reported back in 1938, and then there's a big study in the 70s which highlighted some of these, and then as you can see, the monitoring that's occurred has shown that really starting in the 80s it really picked up. So we got these bad dead zones starting in the 80s. And then this is the number of scientific papers that have been published relating to this. So we're getting these swings from wet year, dry year kind of swings. and we're still seeing those occurring, and there's a lot more interest. The scientific interest is not the only people interested, but it hit the public, and the public imagination was captured by the term dead zone, and so this is one of the diagrams they used for the Mississippi River dead zone, the size of New Jersey, etc. So this has really has become a real issue, and we just did a manuscript that Jeremy Testa and a bunch of students have put together for the Hypoxia Forecast of Chesapeake Bay. We've done for 10 years, and you can see the dead zone gets increasing attention, but also this forecast is becoming part of that vernacular locally. One of the problems with Chesapeake is climate change, and we see this in increasing temperatures. We see it with increasing salinities and, of course, sea level rise. And if you run out these projections for different emission scenarios, Chesapeake climatologically is starting to look more like South Carolina or even Florida in the worst case scenario over time. So Chesapeake is becoming less temperate and more subtropical with these changes. Historically, the land use of the bay pre-colonial was very forested, and what Grace Brush's analysis showed with her paleoecology, looking at pollen in cores, etc., is that there are a huge number of beavers that created dams and retained the water on the landscape with all these little beaver dam reservoirs that occurred behind the dams, and so very amount of nutrient processing occurred on land, and very little ended up down in the bay. In early colonial days, what happened is first thing they did is trapped out the beavers, so there was a lot more water flow directly coming down, and then back in about 1800, they really denuded the watershed and chopped down all the trees and had low intensity agriculture. And then now we've urbanized, and the agriculture has become intensive but smaller footprint. So these changes are ongoing and massive over time. And one of the things fueling that is this growth of population, and it's been a steady growth and still projected to increase. So these pressures will only become greater. One of the things I wanted to, as a literacy thing, is you have to appreciate the unique human cultures and livelihoods of Chesapeake Bay. That's a skipjack, one of those oyster boats that sail-powered. Beautiful Swimmer is a great book about the watermen of Chesapeake Bay, and there's a recent redo of that and a short film by Tom Horton and Dave Harp. Horton's written some beautiful books about the bay. He lived for a year on Smith Island and talked about this culture, that really unique waterman culture out there. And in many respects, American history has been shaped by Chesapeake Bay, and you can see that wherever you go in the bay. This is Jamestown, John Smith, and the founding, that and Plymouth Rock were the two original colonies in the European colonies in North America. We have Fort McHenry near Baltimore, where the War of 1812 was played out, and the end of the Civil War with Washington and Cornwallis down in Yorktown. And then if you look at this map of Civil War battle sites, you can see the majority of sites are located in this Chesapeake region. So there's so many, throughout American history, there's so many things that are related in this region. So Chesapeake Bay is extremely well studied historically. Starting in 1925 when the formation of Chesapeake Biological Lab. This is when I call it the estuarine science phase. This is where estuaries were really fully documented. Most previous research had been blue water oceanography, so here we were focused in on these shallow water nearshore systems. and really define what makes an estuary. And that's the physics of the two-layer flow. It's the biology. It's the geology of the sediments and sedimentation and how they moved around. And it's the chemistry and biochemistry of estuarine waters. And then starting in the 70s, this funded by EPA, a big study that many UMC's faculty were engaged in, was this eutrophication science to really understand the role of nitrogen phosphorus in driving these algal blooms and dead zones. And then starting in 1983, the formation of the Chesapeake Bay program, we ended up with water quality monitoring and coordinated between the states and modeling, starting with a physical model out at Kent Island to the computer models. And now I call this an accountability phase, where we started reconciling what efforts we were, what our investments were looking like, and what was happening, and basically ended in 2010 when we created the TMDL, the Total Maximum Daily Load, which is the nutrient diet, that's regulatory diet that EPA's placed on the Bay. We'll talk about that more when we talk about science and law. And now into the future of looking at ecosystem response and trying to see if we can get a variety of things that are going to improve the Bay and make it more resilient to climate change, etc. And it's intensively managed. So I notice I didn't say, it's best studied, but maybe not the best managed, but it's certainly intensely managed. We have the Chesapeake Bay program, which coordinates through EPA, but coordinates with using the states and local municipalities. And we have goal teams and science input, both at the goal team level with the STAR group that I chair, and then the STAC, which that Don and I have served on, and then input from citizen and local governments and this management board. So it's a pretty complex and highly evolved management program. But you have to ask the question, is it being well managed? And I guess in 2003, there were 4 bits of evidence that challenged the conventional wisdom that it was being managed perfectly well. One was a political scientist based at the Naval Academy, Howard Ernst, wrote a book called Chesapeake Bay Blues and talked about the happy talk that was going on and the fact that we weren't really reconciling with reality. Turning the Tide, Tom Horton had written a book 10 years previously and did a second edition, talked about, really focused on population pressure and how to reconcile that. And then Don co-edited a book called Chesapeake Futures, which took various scenarios of development pressure as well as climate, and said, well, even if we do everything we said we're going to do, that's still not enough. And then what really pushed it over the top was the Washington Post kind of busted them for believing the models and not their monitoring. So that really woke up the Bay program. And so I think the response has been pretty good. In terms of integration, we have these annual report cards that UMC's produces, the Bay Foundation throws one out there, and Bay Barometer tracks a bunch of the indicators through the Chesapeake Bay program. Those all come out annually. The paper that I'll provide for reading is a 2005 summary by Kemp et al. And so there's been a lot of science, probably needs more integration at that scientific level. We certainly have plenty of integration at the sort of public forum. In terms of adaptive management, this is something Don's been pushing pretty hard for a long time, and he kind of blasted the Chesapeake Bay back in 2006 in a paper he wrote. He said, adaptive management is embraced as a central process in coastal Louisiana, but it's not formally been implemented in the more mature Chesapeake Bay restoration. And so finally, and this is, almost, it took them almost 10 years to be responsive to this call. There is an adaptive management section on the Bay program with your classic adaptive management cycle. But more importantly, what they've done is create Chesapeake Stat, which is emulated after the Bay Stat that Governor O'Malley had to track the progress. And so there's progress tracking, there's the decisions, and then the data portal. So far, they've got live the progress. They're still trying to finalize decisions, and then they'll start on the data. So they are making some steps in the right direction. It's slow. It's like turning a battleship when you get this big program. Precautionary principle. Well, this is where I'd say the Bay has got mixed success on this front. Look at the forecast of urban growth for the Chesapeake Bay watershed, and you can see these areas outside the urban centers, the existing urban centers, these peri-urban centers here are just growing at prodigious rates, and so that's changing our landscape in many respects. A lot more impervious surfaces, and so we've got to reconcile the future of the Bay with these growth projections. I think one of the better examples of a precautionary principle was in the crab harvest. The crab level, the crabs were going down, and they finally kind of said, "Oh, we better do something." So they set up some thresholds and targets for female crabs, and basically, Virginia, this is with O'Malley as the governor of Maryland, and Tim Kaine as the governor of Virginia, finally instituted good crab harvest levels so that the Virginia fishermen were not doing the winter dredge of the pregnant female crabs and leaving them to spawn rather than harvesting them. And you can see that there was that and some good weather contributed to some good years, not so good, but the idea is they're finally focusing on the female threshold levels and trying to reach this target to have a sustainable population. So there's some promising signs on the precautionary principle. Sustainability and resilience. Remember this resilience graphic of pre-70s, Hurricane Agnes, 1972, knocking it down to this current state, and then trying to do restoration to get it to a different future state. This is a diagram we made associated after Tropical Storm Lee and Hurricane Sandy came through, and we talked about the seasonality of the Bay with its natural eco-rhythm of things getting heated up in the summer and the spawning oysters and crabs and then big SAV beds, and then the migration internally of the female crabs and striped bass. But then Agnes came, and it came very early in the year, in June, a very early storm, which really happened right when things were going. So it was a total failure of oyster reproduction and a lot of burial of the oyster beds. The grasses got knocked out. Tropical Storm Lee and Sandy coming later in the year didn't have as much of an impact. Lee more than Sandy. Sandy was really a blip for Chesapeake, devastating for New York, but not much for Chesapeake. Tropical Storm Lee was much more, and Tropical Storm Lee was was the third largest flow recorded. Agnes was the first largest, so it had the potential of being devastating, but it wasn't really that bad, partly time of year. So we have to keep that in mind when we look at this resilience.